Hi everyone and welcome back. So today we're going to look at Unit 2.7, Factoring Linear Expressions, and this is page 316 in the textbook. All right, go ahead and put today's date up at the top for me, please. And let's look at the objectives for today. So we're going to find the greatest common factor, or GCF, of two monomials. Find the greatest common factor or GCF of two monomials. All right, so what's a monomial? We'll look at the prefix mono, and mono means one, so it means there's going to be of one term. Okay? Then we're going to use properties to factor linear expressions. Use properties to factor linear expressions. Okay, so we're going to be looking at GCF today, greatest common factor, and we're going to be just factoring linear expressions. Okay, let's take a look. We're going to find the GCF of each pair of monomials. All right, so let's take a look here at the first one. We have a 4x and a 12x. All right, so usually when we think of GCF and factoring, we think of factor trees. And factor trees are one way you can do this. All right, I think if you follow along in the book, they kind of show you the factor tree method. I'm actually going to show you something called upside down division, and we're going to use that instead. All right, so what we're going to do is we're going to make a box. Okay, now this box should look familiar to you. We used this when we found our denominators for fractions. All right, we can also use this to find greatest common factors. So we're going to put a 4x here and a 12x here. All right, so then you ask yourself, what's the highest thing that goes into both of these, just like we did with fractions. In this case, you would say 4. All right, so 4 goes here. Now they also have an x in common, so x also goes into both, so we put 4x here. Then what you're going to do is divide like we did before. So we're going to have 1 here, and then we have just 3 left here. Okay, now 1 and 3 do not have any other common factors, so then the answer is 4x. Okay? All right, let's take a look at B here. So we have 18a and 20ab. All right, so we think, what's the highest thing that goes into it? Well, we know 2 for sure is going to work. And let's just try that first. So we know a 2 goes in, and then look at the letters that match. We have an A as well. So we know 2A is going to for sure work. All right, so if I do 18 divided by 2, that's going to be 9. A divided by A is 1, so we have just 9. And then we have 20 divided by 2, that's 10. And then we have A divided by A, which is 1, and then B left over. Okay, so what I'm left with at the bottom here is 9 and 10b. 9 and 10b do not have any common factors, so 2a is my common factor. All right, so again, you're dividing, just like we did when we did fractions, okay? You're going to take 18 divided by 2, so you divide by what the factor was, put that underneath, and then double check that you've got all of them. All right, let's take a look at 1a. We had 12 and 28c. Oops, let me write that a little bit different. There we go, 28c. All right, so when we have 12 and 28c, we ask ourselves, what's the highest thing that we can easily see that goes into it? Obviously 2 works because they're even, so keep going from there, and we'll see that 4 will actually fit into both of them. So let's try 4 first. There may be something else, but we'll try that one first. Okay, then we divide. So 12 divided by 4 gives us 3. 28 divided by 4 is 7, and then we have a c left over. So then I look at the bottom, do 3 and 7c have common factors? Of course, other than 1, and that would be no. So the answer is 4. All right, let's take a look at 1b. So we have 25x and 15xy. All right, so when I have 25x and 15xy, again, I ask myself, what's the highest thing that goes into both of them? The obvious one that comes up in our minds is 5, and then they also have an x in common, so it's going to be 5x. Okay, let's divide it just to make sure we do have all of them. So we have 25 divided by 5, which is 5. X is going to go away, so that's just 5. 15 divided by 5 is 3. The x goes away, and I'm left with y. So I have 5 and 3y down there at the bottom, and that's not going to work, so we just have 5x. All right, let's take a look at 1c. So I'm going to do something just a little bit different on this one just to show you what happens if you can't find the greatest common factor the first time. This is just a really quick way to show you how to do it. So let's take a look at this one. So we have 42mn, and I have 14mn. All right, now we're going to divide. Well, what do we divide by? Well, what do we know for sure goes into 14 and 42? My first one initially is 7. Okay, maybe there's something else, but let's just try 7 here at the beginning. And then look at the letters. They both have an M in common and an N in common, so we can bring those out. So we're going to have 7mn. All right, now we're going to divide. So 42 divided by 7 would be 6, and then the letters have canceled, so that's it for that one. I have 14 divided by 7, which is 2, and those letters have canceled out there as well. So what I'm left with is 6 and 2. So you're like, oh, wait a minute, though. That's not prime numbers, or they don't have common, or they do actually have common factors. Okay, so what do 6 and 2 have in common? We're just going to bring down like this and do another one. Okay, so what do 6 and 2 have in common? And of course, the answer is 2. So we're going to do 2 right here. Redivide it, so that's going to give us 3 and 1. Okay. Now, what do we do with these two numbers? We're going to multiply these together, and that's going to give us 14mn. Okay, so 14 is actually the greatest common factor along with m and n. Okay, so if you can't figure out what the highest one is the first time, just pick something, divide by it, and then see what numbers are left. Okay, you should get the letters, obviously, right away the first time, so it should make it easier. But get the numbers down there at the bottom, and if you see something else still matches, just divide one more time and then multiply your two factor things together. Okay, that's the easiest way to do it. And if you're doing factor trees, this is one where it's going to take you a little bit to draw all these out. I like doing these because they're so much faster. Okay, let's take a look at the next ones. All right, so now what we're going to do is we're going to use properties to factor linear expressions. So they're not just monomials. Mono means one. These are considered binomials because there's two terms. Okay, so let's take a look here. So we have 3x plus 9. Well, we're going to do the same thing we did the last time. We're going to make our little box and write 3x plus 9. Okay? Now, what you do is you ask yourself again, what goes into 3x and 9 that's the highest and most that we can pull out? In this case, we can just pull a 3. All right? Now, I'm going to divide, so what I'm left with is just x by itself. Okay, it's 1x, of course, but that means x. And then 9 divided by 3 gives us 3. Okay? Then what they actually want you to do is you're going to write this in factored form. We're not finding the greatest common factor, we're factoring it. That's two different things. The greatest common factor is finding what goes into them. This wants to know how it's factored. Okay, so what we do is then you bring your 3 down, you bring a parenthesis down, and then what's on the bottom is what goes in the inside. Okay, so this is actually my answer. All right, let's try it again. So we're going to do 12x plus 7. All right, so it looks like the only thing that's going to go into that is 1. All right, so if I put a 1 here, that means I'm just going to get everything else again. So what happens is when you can't factor anything else out, then you just write cannot be factored, which just means it's not going to work, okay? So if 1 is the only thing you can take out, then that means it cannot be factored. All right, let's go ahead and try the got it questions by ourselves. And let's take a look. So it says factor each expression. If the expression cannot be factored, then write cannot be factored and use algebra tiles if needed. So it's really difficult for me to show this with algebra tiles just because of the space we have. So I'd rather not go that route. I mean, if you want to try to figure it out, you certainly can, but I'm not going to show it that way. Okay, so we have 4x plus 28. All right, so what's the highest thing that goes into 4x and 28? That would be 4. And then that's going to leave me with x plus 7. So it's 4 times the quantity of x plus 7. So if you haven't figured this out, what we're really doing is, remember in the previous lessons we did distributive property? Well, they gave us the answer to what the distributive property question would be. We're trying to find what the question is. Okay, so really we're just working backwards. Okay, I probably should have said that earlier, but that's really what we're doing here. All right, because we learned to take 4 times the quantity of x plus 7, take 4 times x, 4 times 7, and get 4x plus 28. Okay, we're working backwards now. Okay, let's look at 2b. So this one is backwards, but we're going to leave it exactly how it is. Okay, now since it's addition, yes, you could technically move it around, but let's just keep it in the same order that it is. So we know that a 3 is going to come out of this one. So 3 divided by 3 would be 1. And then 33 divided by 3 would make it 11, so that makes it 11x. So this is 3, parenthesis, 1 plus 11x. All right. We try not to switch the order whenever we're factoring. Sometimes in upper math we will, but for the most part, for us, we're just going to leave it the same. All right, let's take a look at the next one. So I have 4x plus 35. So we draw our box, and right away we ask ourselves, what's the highest thing that can go into both of these? And the only thing I can think of is 1. So since 1's the only thing that can go in, that means this cannot be factored. All right, let's look at example 3. The garden at the right has a total area of 15x plus 18 square feet. Find the possible dimensions of the garden. All right, so we're going to factor it. Okay, so we're going to take 15x plus 18. All right, so we're going to take a look and figure out what's the highest thing that goes into 15 and 18. That would be 3. And then we're going to divide, so that's going to give us 5x. And then plus 6. All right, so the dimensions will be 3 by 5x plus 6. Okay? And actually that's feet. So let me put feet here. 3 feet by 5x plus 6 feet. There we go. Okay, so if I multiply those back together, I would end up with my 15x plus 18. Okay? So just remember that area is length times width. So this is my width, and this is my length. We take length times width. Okay, so we're multiplying them together. Yes? All right. Okay, so let's take a look at 3a and 3b. Okay, go ahead and pause it and try these on your own. And let's take a look. So we're going to look at financial literacy again. The Reyes family has saved $480 as a down payment for a new television. If X is the monthly payment for 1 year, the expression 12X plus $480 it represents the total cost of the television. Factor 12X plus 480. So we're just factoring this one out. So we just got to do 12X plus 480. Okay, so let's go ahead and think about what goes into both of those. That would be 12. I'm going to be left with x here, plus, and then I have 48 divided by 12 would be 4, and then hook the 0 back on, so that would be 4d. All right, so put that together, so it would be 12 times x plus 40. I guess I should put a dollar sign on there. There we go. All right, let's look at letter B. Jesse wants to put down $100 toward a new computer and will pay it off in 6 months. If y is the monthly payment, what expression represents the total price? Okay, so for this one, he's going to make 6 payments, and the payment's going to be his monthly payment, which is y, and then plus his $100. All right. Oh, wait. That's not right. Hold on. Okay, it should be 6y plus 100. Sorry. Just 6y plus 100. He's doing 6 payments and then plus $100. My bad. I thought he was saying something else. Sorry. Okay, so just 6y plus 100 is all you gotta do for that one. So 6 times the number of payments and then plus the $100. That represents the total price. All right. Okay, that brings us to the end of this lesson. Thanks so much for watching. Give me a like and subscribe, and I'll see you next time. Bye.